and welcome back to Sustainability Ventures, where we separate climate evidence from climate exaggeration. You've probably heard this phrase before. We've crossed a tipping point. After this, collapse is inevitable. There's no way back. Tipping point scenarios dominate climate headlines, documentaries, and policy speeches. They're emotionally powerful. They're urgent. But today, we're asking a harder question. Do most climate tipping point claims actually have solid scientific backing? This is not climate denial. This is about scientific precision and why overstating certainty can undermine real climate action. In science, a tipping point has a very specific meaning. It refers to a threshold where a system shifts abruptly and irreversibly into a new state. Classic examples include a lake flipping from clear to permanently algae-dominated, ice sheets losing structural stability, or certain ecosystems undergoing regime collapse. True tipping points involve non-linear behavior, clear thresholds, and limited reversibility. The problem? Many climate claims use the phrase loosely, without clear thresholds, without proven irreversibility, and without strong observational evidence. Most tipping point warnings come from models, not direct observations. Models are essential tools, but they are not crystal balls. They depend on assumptions, parameter choices, boundary conditions, and incomplete understanding of feedbacks. Small changes in assumptions can dramatically alter outcomes, yet public narratives often present worst-case model outputs as near certainties. Life cycle lesson applied to climate modeling. A projection is not the same as empirical proof. Earth systems are massive. Oceans, ice sheets, and ecosystems have enormous inertia. They respond slowly, often over decades or centuries. While change can accelerate, most systems do not flip overnight. Even well-studied risks like ice sheet loss show gradual destabilization, partial reversibility, and strong dependence on future conditions. The popular image of sudden, unstoppable collapse oversimplifies how planetary systems actually behave. Tipping point narratives rely heavily on feedback loops. For example, warming releases methane. Methane causes more warming, which releases more methane. But in reality, feedback strengths are uncertain. Many feedbacks saturate. Others are offset by stabilizing processes. Scientific literature shows wide ranges, not single outcomes. Yet, public messaging often ignores uncertainty ranges entirely. Tipping point narratives thrive in media environments. Why? Because they generate fear, urgency, clicks, and political leverage. A headline that says, "Complex, uncertain risk with multiple pathways" doesn't travel far. But "Scientists warn we've passed the point of no return" spreads instantly. The result? Public understanding drifts further from scientific caution. When policies are justified using absolute tipping point claims, two risks emerge. First, if catastrophic collapse doesn't occur immediately, public trust erodes. Second, fear-based messaging can trigger paralysis instead of action. Effective policy needs probabilities, timeframes, trade-offs, and adaptation pathways. Science works best when it informs decisions, not when it's stretched into inevitability narratives. Climate change is serious, but seriousness doesn't require exaggeration. Tipping point narratives often replace probability with certainty and science with storytelling. Real climate action depends on trust, transparency, and evidence, not fear of mythical points of no return. If this video helped clarify the science behind tipping points, like, subscribe, and comment below. Do tipping point narratives motivate action or distort public understanding? Thanks for watching, and remember, good science doesn't need panic to be persuasive. Greenheart.